Yes, sir. Okay. Now, in worksheet 12, you had two questions to solve for system of DEs. First one was x derivative minus x minus y equals 1, y derivative minus x minus y equals 0, x0 is 0, y0 is minus 5 over 2. Now, in terms of new information, there's nothing new. It's a lot of steps involved in solving, but there's nothing new. So for the first equation, I'm going to do Laplace transform. So Laplace transform for x bar minus Laplace transform for x minus Laplace transform for y minus Laplace transform for 1. You know, for a derivative, it's x of s minus x at 0. For just x would be x of s. For just y would be y of s. And for 1, we know the Laplace transformation for 1 is 1 over s. And since x0 is 0, so now I know that it's sx s0 ys equals 1 over s. I'm gonna bring this over. I'll bring this over, so if I bring it over, it becomes y to the s. And if I bring this over, I have s x to the s minus x to the s, and bringing this over 1 to the s. I'll treat this here as equation number 1 for y of s. Now I'm going to do the transformation for this one. So I'm going to do Laplace transformation for this one for y prime, for the s, for the x, for the y, for the 0. For the derivative, you know, it's sy of s minus y0. For x would be x of s. For y would be y of s. And there's no transformation for 0. 0 is 0. And I know y at 0 is negative 5 over 2, and about negative plus 5 over 2, x of s, y of s, 0. So what I'm going to do now, I'm going to put equation 1 into this. So anywhere we see y of s, we're going to replace it by this. So I'm going to just erase to allow myself some space. So here we see y of s. I'll replace it by this. This is number 5. So plus 5 over 2 minus x of s minus y of s, which is this, so minus s or just take the negative of this, so sx of s plus x of s plus 1 over 5 equals 0. So all I did is putting this equation into this equation. I'm going to erase this. Now remember, in fact, this equation I'm going to write here. Y of s equals s, x of s, x of s, y over s. Okay. Now take the s inside, s squared x of s, s x of s. This one is negative 1 now, plus 5, 2, minus x of s, s x of s, x of s, 1 over s equals 0. This is not 5, this is s. You'll see that this and this, they cancel each other. Now, in terms of this one, that's the only one, so it's s squared x of s, negative s, and negative 2s x of s. Now, for the number, they still have negative 1 plus 5 over 2, that's 3 over 2, bring it over minus 3 over 2. And 1 over s, you bring it over negative 1 over s. Take s squared or x of s as a common factor. You have negative 3 over 2. You can combine this into one fraction, 2s. So it would be negative 3s minus 2. So if you do the common denominator for this, you multiply s top and bottom, and the 2 top and bottom. So now I know this is 2s, negative 3s minus 2. So x of s, now this can be factored into s minus 2. You bring it down here, so s minus 2. So we did all the steps and eventually we're able to get to this point. Now we're gonna do partial fraction for this. So be A over the first one, B over the second one, C over the last one. For this one to match original, you need S and S minus 2. No, wait a minute. I want to change something here, because I just noticed that both of them are S. I'll put the 2 here, so like 3 over 2s, and negative 2 over 2 is minus 1. So bottom we have s squared s minus 2. Because the partial fraction for this is a little bit different. It will be a over s and b over s squared, since it's repeated, and c over s minus 2. Okay. A, to match this, needs another s and an s minus 2. B has the s squared, so only needs s minus 2. And C only needs s squared. So we try 0. That tells me it's negative 2b, b is half. Try 2. 2 here gives you negative 3 minus 1, negative 4. 2 cancel, you have 4c, c is minus 1. Since we're out of numbers that cancel anything, I'll try 1. 1 here gives me negative 3 over 2 minus 1. A I don't know, but 1 times here would be negative, so negative A. B I already know is half. 1 here is negative 1. C is minus 1. And 1 squared, so becomes negative 1. You bring the negative half, so plus half, and the negative 1 plus 1. Cancels. This is like minus 1 equals minus a, so actually you'll come to the point where a is actually just 1. Since a is 1, so this is 1, b is half, and c is minus 1. After all of this, to find x of s, we need to do Laplace. This is x of s, so Laplace inverse of x of s is x of t, and you do the Laplace transformation for this. The Laplace transformation for 1 over s, that's 1. For this one, you can follow in this one rule number 3, and you'll see that eventually it's t to the 1, so half a t. And this one, e to the 2t. So this here is x of t. But there are two things that we need to solve for. So after all of this, we only solved for x of t, which is 1 half t e to the 2t. But I erased too much information. Let me see here. Yeah. Remember when we got to the point and we found all the... I don't know if you need to know how to solve for the other one. How about this? I'll do it for the next question. But it's the same technique anyways, because I lost some of the information. I'll do it for the next question, because it's a little bit easier than this one. For the next question, you have, this is question 2, x bar, y bar, x plus y, x bar, y bar, minus x plus y. X is 0 is 0, y is 0 is 1. And I told you, in terms of new information, there is nothing new here. It's the same idea, but it's just long. So we do the Laplace transform for the first one. So Laplace for x bar, Laplace for y bar, Laplace for x, Laplace for y. For x bar, it's, as you know, x of s minus x at 0. For this one, s y of s minus y of 0. For this one is just x of s, and for this one is just y of s. X of s is 0, so this one is 0, and this one is 1. So you have x of s, 0, y of s, minus 1, x of s, y of s. It doesn't matter how you do it. I'll bring this over. I'll put everything here, so y of s minus s y of s plus 1. I'll take x of s as a common factor. So that will leave me with x of s equaling y of s y of s plus 1 all over s minus 1. In fact, I can simplify this a little bit more, but I'll leave it as it is. So this is your x of s. I'll do the Laplace transformation for the second one. Laplace for x bar minus Laplace for y bar minus Laplace for x plus Laplace for y. This one is s x of s 0. This one minus s y of s minus minus plus y of 0. Negative x of s y of s. Knowing that this one is 0, gone, y of 0 is 1, so we get this. So now what I'm going to do is I'm going to put both equations together. So I'm going to put this into this. So instead of x of s, I'll put all of this. Equals negative of this okay. Now it's a matter of trying to simplify this. If I leave the s, if I take negative y of s as a common factor here, it will leave me with s minus 1 for these two, and 1 over s minus 1 and s minus 1 here. So these two will cancel out, still multiplying by s. This is s y of s plus 1. Here, again, this can be simplified by taking negative y of s, and a negative turns into positive y of s. And that would be s minus 1, and 1 over s minus 1. plus y of s. These two cancel out, so what do we have? Eventually you have s y of s over s minus 1 minus s y of s plus 1. On the other side, you have y of s over s minus 1 plus y of s. Again, a lot of simplifying involved. Bring everything over, so you have negative s y of s over s minus 1, s y of s. Bring this y of s, s minus 1, bring this minus y of s, and bring the one negative 1. If you take y of s common factor now, s over s minus 1, s 1s minus 1, negative 1 equals negative 1. If we do the common denominator for this, for this s mean multiplied by s minus 1, and same as this was negative 1. So y of s, you have negative s squared plus s minus 1 minus s plus 1, s minus 1 Now you'll notice that s and s, they cancel each other, and the 1 and the 1, so we have y of s equaling y of s times negative s squared negative s minus 1 equaling negative 1. To move this over, you have to flip it. And minus s squared minus s. I can take minus s common factor. That will leave me with s plus 1. Or simply, I can move the negative up and make it 1 minus s plus 1. Now, this one I can do partial fraction for. So it's a over s, b over s plus 1. bs, try numbers, 0. So a is 1. Try negative 1. So b is minus 2. So y of s now is 1 over s, 2 over s plus 1. Now, to do the inverse for this, 1 over s is t, no, 1 over s is 1, and this is e to the minus t. So all of this to be able to reach the solution for y. It's, in terms of information, there are no new rules or information. It's just hideous. It's a lot of steps involved. I told you that I'm going to solve for this. Now, if this is for y, you also need to get x of t. Or sometimes they might ask you to get x of t. To do x of t, once you get to the point where this is y of s, you put it inside of here. So 1 over s, 2 over s plus 1, minus, you multiply this by s, becomes 1 and 2s over s minus 1 plus 1 over s minus 1. So this one becomes s minus 1. This one becomes s plus 1, s minus 1. Minus 1 and minus, they cancel each other. And the last one becomes 2s, s minus 1, and s minus 1 squared. So you get to x of s, and now here you do the partial fraction again, and then you know what the final. For this question, they only asked for the y. They didn't ask for the x. But to do it, you have to plug it back into the system and work it out. This is the end of worksheet 12, and this is the end of all worksheets. So please review both videos and be ready, because next time will be test 5 and then the final exam. Good luck.